Hello and welcome to another video lesson. Particularly in this lesson, I'll be discussing the co-located grid before we get into the programming side of it. First of all, it's really important that you understand the difference between a co-located and a staggered grid and where the X nodes and the cell centers are and how to differentiate and calculate them. So this will be a particularly short lesson. And this photo here shows the co-located grid in a summarized way. So you've got your central P node, which belongs to this particular cell, and on the right hand side you can see the E node, which is the east, and the N north node, and the west node, and the south node. Also in simple letters you can see the faces of this particular control volume from now on, which we will call cell. It's a cell and it's got four faces: east face, north face, west face, and south face. Now when you discretize the grid, the east face will hold the xith node, or the ith node, and the west face will hold xi minus 1 node, and the north face will hold yjth node, and the south face will hold the yj minus 1 node. So this spacing can be referred to as delta x of the grid, and the spacing from south to north can be referred to as the delta y of the grid. Okay, so this is the co-located control volume for an internal cell. Now let's have a look at a more important picture in which we will discuss. So it's really important that you understand this particular picture. So I'll try to make it as clear as possible. So we have a total length of 1 meters, let's say 1 meter. Now there is 7 internal control volumes or cells. So it's 1, 2, 3, 4, 5, 6, 7. And at the same time, we also denote some control volumes for the boundaries. So that will be one on this side and one on that side. So that makes it 9 control volumes, but internal 7 control volumes. Now let's look at the spacings. So let's first look at X in particular. Forget XC for now. Let's look at X. So X goes from face to face. So start from here 0. So when you divide it by 7, you get some delta X values. You add that 0.14, 0.28, 0.42, 0.57, 0.714. I have actually removed some decimal places to make some space, and so on until 1.0. And the last, for this co-located approach, we use the last one, similar X, as the node before it. So the last X is a copy of this particular one, 1.0. And with this approach, we can now compute the control volume cell centers. So of course the first one, because it's on the boundary, the XC value will be 0. The second one is still in this first internal cell, but do not confuse it. The value there is at 0.071, and the value here is of course 0.14 and 0.28, the difference divided by 2 plus this value, so it's 0.214, basically the midpoint, and the midpoint again until the last 1.9285, which is between here and here, and the last one will be 1.0. So the point here is that the control volume cell centers for the boundaries will be at the beginning boundary will be at the X, the first node, and the last control volume will be at X last position. Okay, so spend some time to think about this figure. Now we will talk about the interpolation factors. So in a collocated approach compared to a staggered approach, we have to interpolate and calculate the phase values quite often. That's why it's important to understand how to do that. It's rather simple actually. So for the first node, no interpolation is required because everything is on the boundary and the control volume is also on the boundary. So the interpolation factor will be 0. But everything else in the internal region, you have to calculate the interpolation factors. So I have color coded here the dx1, which is the spacing from the control volume cell center to the face, and dx2, which is from one control volume to the next control volume. So dx1 divided by dx2 will give you the interpolation factor for this particular control volume. So what does that mean actually? Let's say we have a value of, let's say, u velocity equal 1.0 at p, and of course this will be the e node now, and here if it was 2, then at the cell face the value will be 1.5 because this is a uniform spacing. This grid has uniform spacing, so without even calculating, you know that the interpolation factors will be half or zero 0.5, because this distance divided by this distance will give you an interpolation factor of 0.5. So the cell face value will be whatever the value is at p multiplied by half plus whatever the value is at e multiplied by half. But when you go to the last uh, control volume, the interpolation factor there will be 1.0. Okay, so in the next video lesson we will start to code this particular grid, and then we will have a hopefully a better understanding of what is actually happening. But if you get lost, do refer to this picture. I have tried to make it as clear as possible. Thank you.